We're going to continue our unit on circles. Today we're going to talk about inscribed angles and inscribed figures. What those are angles that are where the vertex of the angle or the figure is located on the edge of the circle or the circumference of the circle. We'll find out some connections with the measures of those angles as we begin working today. Start off with an exploration. I would like you to draw a circle. There might even be one on your notes already. And what we're going to do once we have that circle, what we want to do with that circle, and get your compass out and draw that, is we're going to take our circle and we're going to make some inscribed angles and see what connection there is. So make your circle, mark the center, and we're going to mark the center point P. Put 2 points on the edge of the circle, R and S, and then we'll put 3 other points, T, U, and V, somewhere else on the circle. It doesn't matter where they are. And then with your straight edge, what you're going to do is you're going to connect these. So we're going to connect RPS. We're going to make another angle RTS, another angle RUS, and another one RVS. Okay, so take some time and create that, and then what you're going to do is you're going to measure each of those angles. So with your protractor, you're going to measure each of those angles and record those on the chart, see what kind of a measurement you get. So go ahead and do that. Restart the video when you are ready to check what I got and compare it with your answers for your specific triangle, see what kind of connections we can find. All right, so when I measured RPS, we call that the central angle since the vertex is in the center. I got 80 degrees. And then my 3 inscribed angles, RTS was 40 degrees, RUS was 40 degrees, and RVS was also 40 degrees. And so you should have noticed some similar results with your own figure, is that the inscribed angles were half of the central angle. And notice that all of these inscribed angles, they all have an intercepted arc of RS. So RTS intercepts arc RS. Same with RUS and RVS. They all intercept the same arc, which is why their measurements are all the same. And so, we see the connection there with the central angle and the inscribed angles. We're going to take a look on GeoGebra and see some of those connections as well in motion. So notice I have the circle A. We'll take a look at this in motion here, but if I measure a central angle, and I can change that angle if I want. Maybe I can't. There we go. So I can change that angle, but notice arc BD and the central angle. We've looked at that before, that those are the same measure. And then when I put the inscribed angle that connects, the inscribed angle is the angle where the vertex is on the edge of the circle, and it intercepts the same arc, AB. Notice that it's always half of the arc or half of the central angle. No matter what size the circle is, it's always half. The other way we can see that connection is with triangles within a circle. Notice this central angle and its inscribed angle this is half of it. Same with this one. The inscribed angle is half of this central angle, and the blue one as well. The other thing to notice is that we have 180 degrees in a triangle. Notice if these angles are all the inscribed angles, the central angles will all be double, and those add up to a total of 360. So there's a 360 degree rotation around a point, and 180 degrees in that triangle within the circle. So that's the connection that we'll work with today. So as we begin to work with that, let's just put some of that information down in our notes. Maybe it's already written down for us. So the measure of the inscribed angle is 1/2 the measure of its intercepted arc. So if I have arc AB, angle ADB is going to be half of that arc. So as we take a look at some examples here, measure of angle A. Well, angle A intersects arc BC, and if arc BC is 84, angle A has got to be half of that, 42 degrees. Why don't you take the time to work on numbers 4, 5, 6, 7, and 8, and see if you can get the measures of those angles or arcs as indicated. Restart the video when you're ready. Okay, so measure of angle G is going to be half of this arc. This is 70 and 120, 360 degrees total around the point in the circle. So the total of the arcs is 360, so there's 170 left for FD, which means angle G is half that, 85 degrees. Here at angle N, this arc is 160. Here's a semicircle, so that's 180, so I only have 20 degrees left over. So the angle's half that, 10 degrees. RS is the intercepted arc for angle Q. If angle Q is 67, the arc has to be double that, 134. Arc VU, here's my semicircle, so that's 180. If angle U is 30 degrees, arc TV is 60, which means I have 120 left for VU. And then WX, well, if this arc is 110, angle X is 75, the intercepted arc is double, 150, so I have 100 left for arc WX. Okay, then the other thing that we talked about with the inscribed angles, if they intercept the same arc, they're going to be congruent. So just like we looked at in exploration, those hit the same arc. They intercept arc AB. So if they both intercept arc AB, they've got to be congruent. So if we look at this figure here, which pairs of angles are congruent? Well, I see arc WZ and WXZ intercepts the same arc as WYZ. So those would be congruent. Okay, and then the last thing we talked about was the polygons, the inscribed polygons. It's an inscribed polygon if all the vertices lie in the circle. A circle that contains the vertices is called a circumscribed circle. A circle drawn around the vertices of the figure. We talked about that when we found our perpendicular bisectors. In a triangle, we found the circumcenter. So, if a right triangle is inscribed in a circle, the hypotenuse is on the diameter, because that's where the perpendicular bisectors would meet. Conversely, if one side of the inscribed triangle is a diameter, then the triangle is a right triangle. The angle opposite the diameter is the right angle. So if our diameter is here, choose a different color that's a little bit clearer. AC is the diameter, so angle B would be the right angle. So just as long as that triangle's inscribed in the figure, that will always be true. And finally, as we talk about quadrilaterals, they can be inscribed in a circle if and only if the opposite angles are supplementary. So if D, E, F, and G are all on circle C, D plus F are supplementary, and E plus G, those are supplementary. And all three of them would add up to 360 because that's how many degrees are in a quadrilateral. So if that's the case, this is an inscribed quadrilateral, so 68, angle C and A will be supplementary. So Y will equal, if we do the math here, 180 minus 68. 180 minus 68 is 112 degrees. My math is correct. And then X would be supplementary. B and D are supplementary. So it would be 98 degrees. Okay. I'll let you solve number 6 on your own. Pause the video, restart it once you're ready to see the solution. All right, so angle T and V, opposite angles, so they're supplementary. So 8x plus 10x is 180, which means x would be 10. And S and U are opposite angles, so they would be supplementary as well. So C plus 2C minus 6 would equal 180. And then C would be 62. So that's all there is today. We learned about the inscribed quadrilaterals and triangles. We also learned about the intercepted arc and found out that that intercepted arc, when we have an intercepted arc, the inscribed angle, the angle where its vertex is on the circle, will be half of that intercepted arc. And then it would also be half of the central angle as well. So apply that in your work, and if you have questions, I can handle that in class.